Did you find what you needed out of there?
Yeah.
Okay.
When you say next class, you mean next Wednesday?
Wednesday, yes. Yeah. Monday, our class will be like 10 minutes long, so we won't get anything done.
I don't count that as a real class.
Since the classes are so short on Mondays, will it count as an actual on your,
It only takes 10 minutes of missing a class to be counted absent, so.
Good morning, Greenville High School. It is Friday, April 14th, 2023. Will you please join me for a minute of silence? Thank you very much. Will you please stand as you're able for the pledge? Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Today we have a special treat. In honor of National Poetry Month, our very own Elise Whitfield will be reading a poem she has chosen for today.
Why is my verse so barren of new pride, so far from variation or quick change? Why with the time do I not glance aside to newfound methods and to compound strains? Why write, I still all one, ever the same, and keep invention in a noted weed, that every word that does almost tell my name, showing their birth and where they did receive? Oh, sweet love, I always write of you, and you and love are still my argument. So all my best is just an old word new, spending again what is already spent. For as the sun is daily new and old, so is my love still telling what is told. Thank you.
Thank you, Elise. That was beautiful. That's it for now. I hope everyone has a fantastic Friday.
Alright, so we've got 2 things we need to get accomplished today. 2 or 3 things, however you want to count them up. So here in a moment, last time I saw you guys, you worked on a book assignment after we did some notes. And you asked some questions, but the questions at the end of that book assignment, you may have had some questions, but you may not have known in time to ask them in class. So if that sounds like that meets what was happening for you, you need to get out that book assignment so that I can take those questions and we can have that checked off. And then if you didn't have any questions, the 2 handouts you picked up today together make up this unit review. So some of it is the linear stuff, so point slope form, slope formula, all the linear things, piecewise functions, all that stuff we did the first day. And then some of it is solving quadratics like we did the second day. And then near the end of that review is some of the graphing stuff like we talked about last class. So those are the really 3 days of Algebra 2 review that we have done, and those add up to make that review, and then that review should help you identify what you need to study for the test. So on our agenda up here, I do have down that our assessment is next class. I'm not counting Monday because on Monday our class is like 15 minutes long or something, so that's really on Wednesday. Monday's not a real class, but just to be clear. Okay, so if you think you have some book questions, go ahead and get those out and let me know which ones you'd like me to discuss with you. Otherwise, go ahead and start on the review. And there are solutions on my website to that, so you can check those as you go along. And then, of course, I will interrupt you a few times throughout the class period to give you some chances to speak up and get clarification before you see the same stuff on the test. Yeah. 57. Okay, so for those of you that had question 57 out of the textbook, it says we've got 2 quadratic functions, one that opens upwards and one that opens downwards, or find 2 who have the given x-intercepts. So this is kind of like working it backwards, because usually what happens is you have a factor, you set that factor equal to 0, and then it tells you a 0, which is the same thing as an x-intercept, as long as it's a real number. So to get -3 as an x-intercept, we need a factor of x plus 3. To get 3 as a intercept, we would need a factor of x minus 3, because that's what equals at 3. So just a general rule of thumb there is you can just do x minus each of those. X minus this gives you a factor, x minus this gives you a factor. Now, this one, if I FOIL it together, I would have x squared minus 3x plus 3x and minus 9. This would be one of my answers that opens upward, because a is positive. That's how I know it opens upwards. But to get a one that opens downward, and to still have these, all I really need to do is multiply this by a negative. It doesn't change the x-intercepts because this still equals 0 at 3, this still equals 0 at negative 3, and negative 1 doesn't equal 0. And if I FOIL that stuff together, I'm still going to get this same thing, but then distribute the negative. And then this would be an answer that opens downward. And I know that because the a value is negative. So change the x-intercepts and the factors, multiply them together. If a is positive, it opens upwards. If you need it to open downwards, just multiply the whole thing by negative. Doesn't mess up the x-intercepts, but does change the, it flips the whole graph upside down. Okay, other book questions? Yeah, Michael. 68. All right, 68. I really like this question. I just wish the function was maybe not quite as messy, because we pretty much have to use a calculator here for these numbers. But A is this really big fraction, B is also a fraction, and C you could think of as a fraction as well. But basically, this question is, how high is the ball? This is supposed to represent a football being kicked or punted. So it's going to look something like that. And part A wants to know how high up is the ball when it's punted. So the graph kind of gives us a visual here. Really, it's not using math terminology, it's trying to use real world terminology, but where the ball, how high the ball is when you're starting off would really be the y-intercept. So plug 0 in for x, plug 0 in for x, solve for y. The ball was 1.5 feet up when they punted it. So again, just instead of asking for y-intercept, something very abstract, they're just putting some context behind the question. Part B, what is the maximum height of the punt? So visually we can see that's right here, and we would be interested in the y value. How high does that go? So again, to me, this is like, instead of saying what is the min or max value, it's like you're trying to find the vertex. So for this one, this is where, you know, I mean, you could do it by hand, you'd still need a calculator to do the arithmetic, but realistically, I would suggest just graphing it. So give me a second to get it typed in. Now this doesn't look like a parabola, but I know it should be because it's a quadratic equation. Let me make sure I typed it in correctly. Yeah, it's quadratic. So all that's really happening here is I'm just not looking at enough of the graph. So to see more of the graph, you guys either need to go to Zoom and try one of these things, which is very hit or miss, or better yet, window. Like, I know I need to go higher than this, so if you go to your window settings, you should change Y max. Y max is telling it how far up it should graph. So instead of going up to 10, let's say, I don't know, go up to 50. Okay, that might be enough, I don't know, but going to the right 10 is certainly not enough. So change X max to, I don't know, it's pretty much guess or check. So I'm guessing X max at 100. So I'm starting to see more of a parabola, but it does need to go higher up for sure. And maybe more to the right. As long as you don't make those numbers crazy big, it's better to be a little bit too much than too small. So I'm almost there. Y needs to be a little bit bigger. I think X is probably fine, but it might look like a better parabola if I make that a little bit bigger too. So this is supposed to be a visual of the football. So we are interested in the vertex if we want to know the highest point of it, but specifically the Y value. So with your calculator, if you just click trace and try to mouse over where it is then that's going to be a very rough estimate. You don't want to do that. Under second trace, this is where your calculator can help you find these things, exact values and not just rough values. And so option 4 says maximum. This is certainly a maximum. So left bound, David, you get my pass? So left bound means make sure you're, because a function can have multiple maximums, so your calculator's not going to guess. I mean, I guess if it was really smart, it'd say, hey, wait, this is just a parabola, so there's only one maximum, so it could do it for you. But they haven't gone that far with programming yet. So left bound means you need to put the cursor to the left of the maximum you're trying to find before you hit enter. Then it will ask for right bound, which means make sure your cursor's to the right of the maximum before you hit enter. Depending on how new your calculator is, you might see these little lines. And basically what you're telling your calculator to do is find the maximum that's trapped in between these somewhere. Guess sometimes helps it speed up, but there's not much for it to try here, so I'm just going to hit enter to skip guess. And then basically your calculator bounces back and forth between those numbers, and then it quits when the y value doesn't continue to get any bigger. So it looks like it reaches a maximum at 113.9 feet, but the height of the football, which is what we were trying to find, is about 104.016. 104.016. And that's in feet. So again, instead of just generically asking you for vertex, this one is trying to say, here's a real life problem where you would maybe care to know something about the vertex. And then along the same lines, last part of the question, how long is the punt? So looks like they started off at 0. Looks like it hits the ground here. So this would be the answer to part C. And so that would be the second x-intercept. When we graph this, there's another one over here, which would represent like backwards in time. That obviously didn't happen. We're interested in this x-intercept. So my graph looks pretty good, but it looks like it's coming down, and I need to see further over here to see what's going on. So I'm going to make this x max even bigger. That tells my calculator to graph even further to the right. And so part C comes from this. Now same thing, you don't want to do trace and try to just get close to it, because like this cursor jumps a lot. Like it's jumping 2 or 3 values every time I click it. So instead, you need to do second trace, and instead of picking maximum this time, I'm going to pick 0. X-intercepts are called zeros because that's where it makes the function equal 0. So left bound needs my cursor to the left of the 0 I'm trying to find before I hit enter. Right bound needs my cursor to the right of the x-intercept before I hit 0 or hit enter. And then hit enter to skip guess, and then it will bounce back and forth until it finds where y is 0, and then we can see where that happens with several decimals of accuracy. Looks like the punt was 228.643 feet. 228.643 feet. That would be that value. So, just a quick example of where you would care about vertex, x-intercept, and y-intercept, what they might mean in the real world. So, anybody else have questions about this one or any follow-up to this? We're good with that? Again, on this one, I really wish the function wasn't quite so messy looking, but honestly, in real life, if you're really measuring something in real life, your equation is going to be kind of messy like this. It's just that if these fractions weren't so bad, we could have found the, well, we found the y-intercept by hand, but we could have found the vertex by hand without a calculator, and we could have found this x-intercept by hand without a calculator. But being messy like that, you pretty much need a calculator. Okay, moving along. Other book questions? 70? Check something real fast. Alright, the profit P in hundreds of dollars that a company makes depends on the amount X in hundreds of dollars the company spends on advertising according to the model Okay, so we've got a quadratic, it's usually up front, but it can be back here as well. So we've got a quadratic. What expenditure for advertising yields a maximum profit? So basically they're saying how much profit this company makes is related to how much they spend in advertising. So X is how much they're spending in advertising, P is how much profit they have. But if you just throw trillions of dollars at advertising, there's at some point you're not getting more customers. You're going to max this out at some point. So because this is a quadratic and A is negative, I know it's going to be a parabola that opens down. So we're interested in this. If this is the graph of P, I'm interested in when P has a maximum value. I'm interested in maximizing my profit. I don't want to spend more. If I spend more on advertising to make less money, that's obviously not good business practice. Likewise, if you land over here and more advertising would end up making you more money, then you want to do that. So ultimately, we want to be able to find the Y value of the vertex here. So I guess you could graph this in a calculator with these numbers, but we certainly should try on this one to do this by hand. Might need a calculator for the arithmetic, but so for the vertex, the X value of the vertex, we can find that by doing the negative B over 2A. So negative B over 2 times A. Now notice this is not in standard form. The first number's not A, the second number's B, but the third number's not C. You can't assume it's A, B, C unless it's in standard form. A is the coefficient of x squared, B is the coefficient of x, and C is the constant. But I guess you can rearrange those if you want to. So we get negative 20 over negative 1, which is 20. So according to this, we should spend, when x equals 20, which is how many hundreds of dollars. So we should spend $2,000. That's how much advertising you should have that would give you the max profit. So that's the, yeah. It says X is in hundreds of dollars. That's why I'm saying 20 becomes 2,000. But it didn't ask us to find what our max profit would be. It wants us to find out how much we should invest in advertising, which would be X. So that's all we needed for that one. Okay, anything else about this one? I don't know, this is kind of a sidebar, but I always wonder why students don't ask like this type of question. Like someday if you get a business degree and you're working for a company, they're certainly going to expect you to be able to maximize this stuff. That's why they're paying you money. They're not just giving you a salary to just come into work. They're expecting you to help them make money, not spend their money. But like in a situation like this, yeah, it's a vertex. You're trying to find this vertex. The X value means something. The Y value means something. But like this equation, do you guys understand like where this equation might come from? Like, because if you're in a job someday, your boss isn't going to say, hey, by the way, here's our profit equation. Tell me what the max is, right? So do you guys just accept that these equations are just told to you and you don't need to know where they come from? Okay, well, then you graduate and then what happens? You want a job, right? And any job's fine for a while, but then eventually someday you want a good job. You want a job you're happy with, a job that makes you money, good money. So, then what? think the thing that maybe we don't focus enough in Algebra 1 on is stuff like this, like where this could come from. Like computers can do that stuff. If you give it some data, if you say, hey, we spent $1,000 in advertising and we got this kind of revenue, and then we spent $50 at advertising and we got this kind of revenue. If you have a set of data like that, and you probably did like linear regressions and quadratic regressions, but anyway, the more data you give your calculator like that, you can ask your calculator to come up with a quadratic regression, which is basically an equation that fits the data you gave it. So like maybe this would represent the data of things that they had tried, but your calculator can pretty much give you a good average of like what's actually happening, and then you can predict what you should do. So that's how you would ever come up with that. Sorry, I don't know why all of a sudden that bothered me, but it's important for you guys to know, like, it's like you just accept this and you can kind of see how this plays into real life, but if you don't know where this is going to come from too, then I don't know.
I thought you meant like where it was actually coming from, not just like plugging data into a calculator and it correct. It's like, yeah, I can do that.
Yeah. Do y'all remember doing like linear regressions and quadratic regressions? Does that sound familiar?
Mm-hmm.
Like in your calculator, I don't want to get too much into this, but like somewhere in so like if you go to stat, edit, so you can just give it a bunch of data. We could say like, I don't know, I spent $5 in advertising and we only made $60 in revenue or profit, whatever. Then I spent 50 and then my revenue was, I don't know, 165. If you give it enough data points to work with, then under stat test or calculate, you have to tell it like what kind of curve you think it's going to be. Do you think it's completely straight? Like the more you spend on advertising, the more you make in money? Or is there some point where you're throwing more money at it and eventually you're not getting the return, so like a quadratic? And then you could select that, and then it gives you an equation that's like an average of those points you gave. So it tries to guesstimate like what the curve would look like. But that is how you would come up with an equation that you could actually use and find things about to actually make your business or someone else's business more efficient. So. Okay, I'm done with that. So more book questions? Yes. 73. I also like this one. This used to be a pretty common type of question on math contest. But it's like this person's got so much fencing to use. In this problem, it's 200 feet of fencing. And they need 2 different pins out of it. So they make like one big fenced-in area, and then they put a fence in between them. So I guess they can put like different kind of animals that are not supposed to mix in there. And if you can't, I mean, buying more fencing costs money. But what you can do is you can set up your dimensions correctly where you're going to maximize this area. So because this is a rectangle, you could say that the area is length times width. Within the question, they say call this length x, call this length x, and call this length y. So instead of calling it length, I might call it 2x. And instead of calling it width, I might call it y. And the first part of the question says find the area as a function of x. So this is almost good enough, but this is right now a function of x and y. We want a function of just x. So instead of saying y, we need to put what y is equal to in terms of x. So we can use this fact that we have 200 feet of fencing, but you have to realize if this length is x and this length is x, then these lengths are x as well. And if this length is y, this length is y, and then the one that often students overlook if they've never seen this before You also are putting a fence here as well. That's a length of y. So your 200 feet of fencing have to have 4 of these lengths and 3 of these lengths for this type of question. But you could subtract your 4x over, and you could divide both sides by 3. And now I know what y is in terms of x. And so then there's the first part of the question. That's the area of that rectangle in terms of x. Length was already in terms of x, but to find the width, you had to use this perimeter, add up all the pieces, and solve for y. Okay, but then the interesting part of the question is, what dimension should we use that would produce a maximum area? So, assuming I don't have more money for more fencing, and I still want to utilize as much space as I can, I'm interested in maxing this out. Now again, if these numbers were not so weird fractions, we could do this by hand. We do that quite a bit. But short of that, we should probably graph it in our calculator. So this was my length, and my width was, I'm trying to remember, 200 thirds minus 4 thirds x. Like that. Okay. Now, by the way, as you guys change your window settings, like I haven't changed it from that last question, so those are probably terrible window settings for this one. Of course, you can go into window settings and you can try to type the stuff back in the way you want it to be, but also if you just hit zoom 6 puts it back in standard -10 to 10, -10 to 10. So, you know, sometimes you do something for a graph and then you don't need it anymore. But this one, I can start to see the parabola. If you didn't have a colored calculator, you might not even notice that it did graph that. But my parabola is going to go up a lot more and then eventually come back down. So I need to change the window settings to where I can see what is going on. So I'm going to make Y max be bigger so it goes higher up. And I'm going to make X max be bigger so it goes further to the right. I have no idea what numbers to make those. That's why it's a little bit of guess and check. So I went a little bit too far to the right, but not far enough up. I'll make X max a little bit smaller, but I'll make Y max a bit bigger. Still not enough. Okay, go higher up. And even more. Now remember what I'm graphing here. What I graphed was my area equation from part 1. So what this is showing to me is how much area I would have. If x is 0, you've got no area. There's no fence. Like, it's not opening up at all. If you make x super big, then the length is like all of your fencing and you have no width to your fencing, so you basically have no area as well. But right here is the sweet spot. This is where we're using the same amount of fencing, but we're maximizing the area. So we're really interested in this vertex. So second trace, ask our calculator to find us that maximum point. For left bound, your cursor needs to be to the left of it before you hit enter. Right bound, your cursor needs to be to the right of it before you hit enter. Hit enter to skip guess, and then your calculator will do the rest. Now, it sometimes does have a little bit of rounding error here, so it's trying to say when x is 25, this is how much area you have, but it's got just a tiny bit off here. But when x equals 25 is when we get a max, but they asked us what dimensions should we have. So if this is 2x, I would say 50 feet by, if this is y, and I know x needs to be 25, I could plug that in here. So 200 minus 4/3, and x needs to be 25, which makes y be 33 1/3 feet. So you can't budge on more fencing, but you want the most amount of space. That's what you should do. 50 feet by 33 1/3 feet, and you will get the most amount of area for your, I guess, animals. It was a rancher. Okay, any follow-up to that one? Okay, I think that's most of the last ones, but is there anything else that you didn't have time to ask last time? All of these are great questions, though. Lots of real-life applications with quadratics. Just that's more of an Algebra 2 topic than our topic. That's why we don't spend so much time on it. Yeah. 50 what? 59? Sure. Let's look at this one from earlier, and let's just change some stuff, because it's the same type of question. So 59 wants us to go through -1 and +4. So a factor that would give me -1 as an x-intercept would be x plus 1, because this equals 0 at -1. And a factor that gives me an x-intercept of 4 would be x minus 4, because if you set this equal to 0 and solve, you'd get this. And then if I distribute this stuff, FOIL this stuff together, I would get x squared minus 4x plus 1x minus 4. So there's one answer. This would be the answer that opens upward because a is positive. And then just like how we did this one, if we multiply all of that by a negative, now it opens downward because a is negative, but since I multiplied everything by a negative, it would still have these factors if you factor it, so it's still going to have the same x-intercepts. Okay, I'm going to switch back to the agenda here. So again, I will give you guys time to ask questions from your review, obviously, because that is the main thing on our plate today. So I will set a timer here and check back in with you guys after I think you've had time to look at most of the first page. Even if you don't have time to finish the first page, at least time to know which ones you might want to discuss on the first page. know it's kind of early, but just on the front of the front page, have y'all seen any of those questions you want a reminder on? Yeah.
On number 3, when it says rewrite the first two pieces as an absolute value function, what we did there.
Uh-huh. Okay, so what it's saying is if you took these two that you graphed, which looks like something like that. Is that what you have for the first two pieces of these?
Yeah, I was just wondering what it meant.
Yeah, well, that's what I'm getting at, but this part already looks the same.
I'm not that far.
Okay, well, they want you to graph all 4 parts of this, right? The first 2 parts, the first 2 pieces, look like an absolute value function. Remember, absolute value of x is like the v function, and what's different about this one is it's shifted left to. So they want you to say it's absolute value of x shifted left to, if you're just looking at those 2 pieces and what their equation could be. That was it. Yeah. See on number 1? Okay, so it wants a line that goes through a certain point, and then we'll worry about the form later. The form is honestly the least important part here. But to go through a point, I would certainly start off with point slope, because just like its name says, it is set up to plug in a point very quickly. So the point would go, the x value goes here, so minus a negative 4 becomes a plus 4, minus a negative 3 becomes a plus 3, and then the only thing you need left to get point slope would be the slope. So if I want it to be parallel to this line, I know I want the same slope as this line. But looking at this form, this is what's actually called general form. It's kind of outdated. But I can't look at this and tell you what the slope is. So what I would need to do is subtract the 3x over, divide both sides by 4, and then it's in slope-intercept form, and then I can see he has a slope of 3/4, so I also want a slope of 3/4. Parallel lines have the same slopes, perpendicular lines have opposite reciprocal slopes. Then if it, depending on the form question, if it doesn't say, I would say just quit, because that works, that's point slope. If it specifically says it needs to be slope-intercept, then you could distribute the 3/4 and then subtract the 3 over, and then you could have slope-intercept. So, but if it doesn't care, then I would just quit here. Okay. Let me get out of your way again and let you look at some more. I'll try to interrupt maybe 2 more times here, so. know you may not be finished with the back page of page 1, but hopefully you've had time to at least look at all the questions and have an idea of which ones you are going to need to ask about. So, anything from 4, 5, or 6? Number 5? Sure. Let me erase some of this. Okay, so what I did, and I can restart some of this if you need me to, but basically 5 has 4 different functions going on. It's red one, purple one, gray one, and black one. So to write it as a piecewise function, it needs to be in 4 different pieces. So this red one, I saw it had a y-intercept of 0, so plus 0 here, and I counted rise over run to get his slope, and just did mx plus b. And he only exists from 0 to 6. Closed circle, open circle, equals, does not equal. Then I did the same thing for the purple line, but it's a horizontal line, so it should just be y equals a number. And since those all have a y value of 6, the equation would be y equals 6. And he exists between 6 and 8, so that's what I put out to the right. For the gray one, I did slope-intercept again, but I used its slope, so I counted rise over run to get a slope of negative 1/2 reduced. To find his y-intercept, you can kind of see here it dashed. I just continued that slope. If it was going down 1, right 2, then it should also be here because this is down 1, right 2, and it should also be here because this is down 1, right 2. So I kind of just backtracked to figure out what his y-intercept was. Then for the black line here, I had pointed out you can do that. You can find the slope and then you can backtrack and you can backtrack, but it's going to be off the graph. So I'm not saying that you couldn't get the correct answer from that the y-intercept is 16, but since it's off the graph, I gave a different suggestion, and that suggestion was if you know the slope is -1, you could plug in any point on this line that you're sure about, like, and I picked 16, 0. I plugged 0 and 16 into point slope, and then when I simplified it, I distributed the -1 and removed the -0 since it doesn't do anything. Then I get it in slope-intercept, and so that's kind of the algebraic way to know what the y-intercept would be without doing this and trying to guesstimate that it would be up at 16. So, is that enough for that? Okay. And then the second part, I don't know, this is kind of a unusual question, but what could you do to make sure that this is continuous, to make sure that all of these pieces are connected? You really need this one to move up, and we need this point to be here. So if we just move the whole thing up to, rewrite the first piece, if we had shifted that graph all up to, then it would be continuous. All of them would be connected. So I think they're just trying to get you to think a little bit there. Something different. Okay, what else from page 2 that you know about? Okay, I know not everybody has made it to page 3 or the front of page 2, but is there any of those that you know you need help on that I can go ahead and help with before I get out of your way one more time? Okay, let me wait about 10 more minutes, and then that'll give us 10 more minutes of questions before you guys are gone for the day. So my website does have the solutions for you to check as you work through them. I do have quite a few videos on there from other questions other classes have asked, so if those help, that would be great. But if it doesn't fit that, then please make sure you have those ready to ask in about 10 minutes. We're down to about 10 minutes now, so if there's anything you'd like to get answered while you're in class, this is going to be your chance. So even if you didn't have time to try it, just scanning it, you know it's going to be something you struggle with, then you should go ahead and ask. Yeah, Michael? 11? 9? 9. What methods always find zeros? What solving method always finds 0 even if they're imaginary? So that's going to be quadratic formula. Factoring is great if the numbers are not messy, but quadratic formula is the only one that always works, regardless if they're imaginary, nice whole numbers, messy fractions, square roots. It's the main one. Is there one of these ABC parts you want to look at?
I might use number 10.
Number.
You need 9 first before you solve it.
Okay, so on 9, which problems had imaginary zeros? So imaginary is just going to be any of them that have the number I in there, which comes from taking the square root of a negative number. So yeah, you've got to work out those parts first, but at least one of those, I guess, should have I in the answer. So those would be imaginary. So they're still solutions, but imaginary solutions don't show up as x-intercepts, whereas real solutions, real number solutions do show up as x-intercepts. Okay, others? 11. We have this as a vertex and this as a y-intercept. Use the 2 points to solve for A and write a quadratic function in vertex form. So vertex form looks like this. You need to solve for A, H, and K. The easy part of that is H and K because that's the vertex and they gave it to us. So you subtract H, but you add K. So if you wanted to go through 2, 7, you actually want this to look like -2 and -7. This one's opposite, this one's not opposite. I know that doesn't seem intuitive, but that's the way that works. Okay, and the real challenge then is to figure out what A is. If we know what A is, we can substitute that with the number, and then this will be our answer. So what you have to do in this case is use your second point temporarily plug in 1 for y and 0 for x, and that's helpful because it gives us an equation that only has a's in it, so we could then solve using our normal methods, and it looks like a is 2. So if we go and plug that back in up here, now it's got the right vertex because of h and k, and it's got the right a value that would make it go through 0, 1 also. So plug in h and k for the vertex permanently, temporarily plug in the other point x and y so that you can solve for a, and then once you know a, h, and k, just put them where they're supposed to go. Okay, we still got about 6 minutes, so I can help with a couple more if you got them ready. Again, the most commonly asked ones, there are videos on my website, so if you do get to one you need help with, hopefully there is one there for you at least. I'm going to switch this off then. So if you were here, I know a lot of you guys won't be here on Monday. I understand if you're a junior or senior, having to sit in an advisory all day just to go to most of your classes for a few minutes is not ideal. Of course, make sure your parents call you in if they're okay with you missing that day. But on Monday, I will remind you about our test on Wednesday. Also on Wednesday, there's 2 assignments I still need to pick up. One of them would be the book assignment from last class, 107, and one of them will be this review. So if you think there's a chance you're not going to be here on Monday, you probably want to write that stuff down now. 107 and 109, I'm sorry, 107 and 108 will be the last two homeworks I pick up from this unit. I'll open those up in Google Classroom so you'll get a friendly reminder in your email for that. If there's any late, incomplete work that you want more points for, Wednesday will be the cutoff since we'll be doing the testing. And of course, reviewing and studying, depending on how much you need to do, you need to make sure that you do that by Wednesday as well. So you're getting a couple more calendar days, but if you forget about it, then that's not going to help you out at all. So